the past, we've talked about the interior angles of a polygon, but in this video, we're going to be talking about the exterior angles of a polygon. And in the first two examples, we're going to rely on the definition of supplementary angles, and in the second two examples, we're going to be using this formula we've learned before, which tells us the sum of the interior angles of a polygon. So if we look at this first example here, the idea of exterior angles is the angles that are formed if you extended each side of the polygon out into space. So here we just have a triangle, a three-sided polygon, and we know that we have three interior angles here, here, and here. But we can also identify exterior angles if we just extend each side of the triangle out into space infinitely. So with that in mind, we've been given this exterior angle here of 132 degrees, this exterior angle of 120 degrees, and we've been asked to find x. Well, what we need to realize is that each of these exterior angles are just a supplementary angle to the interior angle. So in other words, we have this 132 degree angle. We know that its supplementary angle, this interior angle right here, is going to be 180 degrees minus 132 degrees, because remember, supplementary angles sum to 180 degrees. So if we say 180 minus 132, we're going to get 48 degrees. So we can say this then is going to be 48 degrees, this interior angle. We also know that this interior angle here and this 120 degree angle are supplementary. They're also going to sum to 180 degrees. So we can say 180 degrees minus 120 degrees is going to give us 60 degrees, and so then we know here that the interior angle measure is 60 degrees. Now, keep in mind that we know that the three interior angles of a triangle sum to 180 degrees. So if we say that the sum of the three angles is going to be 180 degrees, we can say that this missing interior angle here is going to be 180 degrees minus 60 degrees minus 48 degrees. And when we do that arithmetic, we're going to get 180 minus 60 is 120. 120 minus 48 is going to be 72 degrees. So we can call this interior angle measure 72 degrees. And now at this point, we come back to supplementary angles because 72 degrees and angle x here are supplementary. So we can say that x is going to equal 180 degrees minus 72 degrees, and 180 minus 72 is going to give us 108 degrees. So then we can say that x is going to be equal to 108 degrees. Now we can do the same thing with a quadrilateral. Here in the second example, we have a quadrilateral. It's a four-sided polygon, and we've been given two interior angle measures, and we've been asked to find this exterior angle measure over here. Well, again, we'll look at supplementary angles, and we realize that this 75 degree angle here and this angle are supplementary, so they have to sum to 180 degrees. So we'll call this y right here. We know that y is going to equal 180 degrees minus 75 degrees, and when we do our arithmetic, we're going to say y is equal to 105 degrees, and so we can say y equals 105 degrees. Now we've been told that this angle y is congruent with this angle x, which means that they have the same angle measure. So since y is 105 degrees, x also has to be equal to 105 degrees. Now sometimes we aren't given a figure, and instead we've been asked a question like this one. We've been told that the interior angle measure of a regular polygon meaning all of the angles are equal and all of the sides are equal, is 165 degrees, and we've been asked to find n, the number of sides of the polygon. So if all we have is one of the interior angle measures, how do we figure out how many sides the polygon has? Well, again, remember, because the polygon is regular, we know that all of the interior angle measures are going to be the same. They're going to be congruent. So we have this formula up here, right? Quantity n minus 2 times 180 degrees tells us the sum, the result of this formula here, is the sum of all of the interior angle measures. So if we want just one of the interior angle measures, we can take this formula here and we can divide it by n, because now this value will be equal to the measure of just one of the interior angles. So since we know that one of the interior angles is equal to 165 degrees, we can take 165 degrees and we can set it equal to this value right here. So we're going to say quantity n minus 2 times 180, all divided by n. Now if we multiply both sides by n, we'll get the n to cancel over here, and we'll bring the n over here, so we'll be left with 165n is equal to, we just have the numerator remaining over here, and we can distribute this 180 across the n minus 2. So we'll get 180 times n is 180n, and 180 times negative 2 is a negative 360. Now if we add 360 to both sides, we'll get it to cancel over here on the right, and we'll get a positive 360 on the left. If we subtract 165n from both sides, we'll get it to cancel over here, and on the right-hand side, we'll be left with 180n minus 165n, which will leave us with 15n. And now to solve for n, we just need to divide both sides by 15, so we're going to get n is equal to 360 divided by 15, which is going to be equal to 24. So the number of sides in this regular polygon is 24. Now what happens when instead of being given an interior angle measure, we're given an exterior angle measure of a regular polygon? Well, in that case, we go back to the idea of supplementary angles, because we know that any exterior angle is going to be supplementary with its corresponding interior angle, right? If you imagine this exterior angle right here, it's going to be supplementary with this interior angle of 105 degrees. So they sum to 180. So that means that the interior angle that's supplementary with this, we can find by saying 180 degrees minus 36 degrees is going to give us 144 degrees. So 144 degrees is now the measure of the interior angle, and we know it's a regular polygon, so all the angles are going to be the same. So just like in the previous problem, we can set this value 144 equal to our formula up here in the same way that we did with 165. So we basically changed this fourth example into the third example by finding the interior angle associated with this exterior angle instead of working directly with the exterior angle. So now we just say 144 is equal to quantity n minus 2 times 180, all divided by n. And again, here we're going to multiply both sides by n and get 144n equals, distributing the 180, we get 180n minus 360. And then here we'll just collect like terms. So we'll add 360 to both sides to make it positive. We'll subtract 144n from both sides. And on the right then we'll get 180n minus 144n is going to give us 36n. And then dividing both sides by 36, we see that n is equal to 360 over 36, which of course is 10. And therefore we can say that a regular polygon with 10 sides has interior angle measures of 144 degrees and exterior angle measures of 36 degrees. And that's how you find exterior angle measures of polygons.